Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thanks again to our Patreon subscribers. As always, we really appreciate your support on our show. This show is a lot of work to put together, and so we really appreciate you.
Yeah, for anyone it's your first time listening, our Patreon is $5 Canadian per month, which is fairly cheap. You get bonus content from myself and Nicole. We do some mini failures that come out every other week. So these are like full episodes of Failurology, but they usually have pretty straightforward causes, or they happened a really long time ago and there's just not enough information to make a full episode of Failurology. So those come out every other week from the regular episodes. They're a lot of fun. I have a ton of fun recording them.
This week in engineering news, we're going to talk about NASA's Perseverance Mars rover, which cored and stored the first sample of the mission's newest science campaign on Thursday, March 30th in the Jezero Crater Delta on Mars. And we've talked about the Perseverance Mars rover before on a previous episode. If I remember correctly, it's the largest and most advanced rover to date, and it has a lot of functionality that previous rovers didn't have. So Perseverance collected 19 samples and 3 witness tubes in the crater and recently deposited 10 tubes as backup cache on the Martian surface as part of NASA's ESA Mars sample return campaign.
I think this is really cool that not only is there a rover on Mars that's collecting some of this data, but there is a way eventually for these tubes and these samples to be recovered from Mars, brought back to Earth, and then analyzed on Earth. Instead of analyzing samples kind of in real time or pseudo real time as they're collected on Mars, these samples are being left for a future mission, possibly human powered, where these samples will be collected, returned to Earth, and then analyzed. I think that is super cool.
Yeah, that is pretty cool. And it takes us another step further into evaluating Mars as a planet, being able to bring the samples back and having more than just a visual look at what's there. Now we're actually able to bring those samples back and test them. And they're going to use those samples to search for signs of ancient microbial life and to better understand the water cycle that has shaped the surface and interior of Mars.
So these samples, they were collected from a diverse range of geology throughout the Jezero crater on Mars. These samples that they collected on March the 30th, these were taken from a rock that has been named Berea. I believe that's how you say it, Berea. And the team that's in charge of this mission, they believe that this rock was formed from deposits that were carried downstream by an ancient river. So one of the benefits of collecting these samples from the Berea rock is that the rover doesn't have to travel to the origin of the Berea rock, and then it can also kind of minimize its travel footprint of also being able to collect samples within the Jezero crater. So like I mentioned, kind of a 2-for-1 data collection.
And it's the same as if, on Earth, if we collected samples from downstream in a river, we're able to somewhat extrapolate that to, or what is there upstream of that location. It's maybe not exact, but it allows you, especially on Mars where travel is somewhat limited, it does allow them to make some extrapolations and do more with less.
So if you want to read more about the rover, check out the link on the webpage for this episode at failurology.ca.
This episode of Failurology is brought to you by Shorts.
They're shorts that are short.
Made by Shorts.
Not to be confused with pants. These are different.
This seems pretty self-explanatory from the name, but yet, here we are, trying to fill the next 15 seconds of advertising time.
Now on to this week's engineering failure, the US Interstate Highway System.
So we've been doing what I call odd failures in these number 5 episode spots, and this episode is no different. The interstate highway system throughout the US is both a marvel and a failure depending on where you are and how you're looking at it. So we thought it fits perfectly in this number 5 spot, number 75. Some of the other odd failures that we've done is OIQ, which is the regulating engineering body in Quebec, their loss of self-regulation. We talked about that in episode 65. We talked about breast implant recalls in episode 55, Kowloon Walled City in episode 45, and the Leaning Tower of Pisa in episode 35. And 35 was the first time we'd done this, and we've just been doing it since. So If you go back to 25, 15, and 5, it's a little bit different. But, the show is an ever-evolving creature.
I mean, I like doing these ones just because usually people don't die in these episodes, which is always great. So they're much less morbid than some of the other episodes or some of the other failures that we covered.
I agree. They are less morbid, and usually they've been surprising. For example, the Leaning Tower of Pisa I thought would be kind of boring. I wasn't really necessarily looking forward to that, but I actually found it so interesting how they started and stopped construction, how they noticed that it was leaning as they were building it, and steps they took to try to prevent that, the fact that it's still standing so many years later, and all the renovations that they've made to keep it standing. I just think that story is it's just much more interesting than I expected it to be. So these are also pretty cool episodes, and there's a lot of things out there. Nothing is black and white. The world is varying shades of gray, and so these odd failures straddle the line between being something that's really, really good and something that's really, really bad. Between the marvel and the catastrophic failure, they kind of straddle that. And I think that's just definitely interesting to talk about and something worthwhile talking about, because I think these are really relatable failures. We can't win them all. So the US Interstate Highway System is over 78,000 kilometers long, almost 49,000 miles, and it's a series of multi-lane divided highways that crisscross the US in a somewhat logistical order. Construction costs for the entire system are estimated to be about $558 billion in 2021 dollars. And a quarter of all vehicle miles driven in the country is estimated to have been on interstate highway system roads. The system connects all 48 contiguous states, which means all 48 states that are touching each other, with Alaska, Hawaii, and Puerto Rico, which are not touching those states, also having interstate highways as well, but obviously not connected because they're geographically separate from those 48 states.
So as far as the history of the U.S. interstate system, the U.S. government had efforts for a national highway system that started in 1916 with the passage of the Federal Aid Road Act, which was going to provide $75 million over a 5-year period for matching funds to the states for the construction and improvement of highways. Back in 1916, not a ton of vehicles out there, not a lot of good highways out there. So this is creating some issues with the development of commerce and the movement of goods, and people are starting at this point to purchase cars. It's kind of in the middle of World War I. So mobilization is starting to become an important thing in the U.S. So World War I, as I mentioned, it did significantly impact kind of the development and implementation of this policy. It's a little hard to build highways in your country when your country is also involved in a war overseas. Unfortunately, this act and this policy expires in 1921. However, this is not the end, obviously, of a national highway system in the States. I mean, we're doing an episode about the U.S. interstate system, so it's developed out of here. So one of the proponents of this was E.J. Mehren, a civil engineer who proposed a suggested national highway policy and plan in 1918 that consisted of 80,000 kilometers or 50,000 miles of 5 east-west routes and 10 north-south routes, which is actually fairly close to what the U.S. interstate system does wind up becoming. So the system was going to pass through every state at a cost of $16,000 per kilometer or $25,000 per mile. In 1919, so after the end of World War I, the U.S. Army sends out an expedition across the U.S. to determine the difficulties that military vehicles would have on a cross-country trip. I think this is a great idea. A good recce like this or a good reconnaissance mission, it's seldom wasted. And on this mission is future President of the United States, Dwight Eisenhower. So this trip, it takes 62 days to drive 5,100 kilometers or 3,200 miles from near the White House in Washington, D.C. to the Presidio Army Base on San Francisco Bay. The average speed of that, or the average distance driven per day, was 82 kilometers per day. So, as some of you may know, I've done some fairly long distance hiking. I have hiked with my own 2 legs more than 82 kilometers in a single day. I've ridden my bike multiple times, more than 82 kilometers in a day. When you're driving a vehicle and you make 82 kilometers in a day on average, that's not very good progress.
For the record, I have never walked 82 kilometers in one day. That is a lot of kilometers in one day.
It is many kilometers to walk in a day. That was kind of when I was in peak hiking shape. I don't think I could do it now. It would be really hard on my legs, I think, to do it, but I'd been hiking for a couple months at that point, and we had some mileage checkpoints that we wanted to hit, and it just so happened that things lined up, and we crushed out a couple really big days.
Brian's also explained to me on probably more than one occasion that there's a phenomenon called referred to as getting your trail legs under you. And so there's this, I think, thing that happens 2 weeks into a long hike or a through hike where your body just kind of adjusts to it and you're able to hike much further and longer than you thought that you could.
Yeah, that's pretty much how it works. Yeah, it takes about 2 weeks to a month, I guess, depending on how many miles you do per day, where you just kind of get in a routine and your legs are kind of used to just hiking very long distances every single day.
So back to this trip that they did. How did the Presidio Army Base in San Francisco get built, and how did they get to it before? Because I'm assuming this is before airplanes. If they weren't able to drive to it, how did they make the base in San Francisco? Did they get there by boat?
So the army base in San Francisco, there was intercontinental railways that were in place across the state. So rail transportation was still a thing, at this time in history. But yeah, like you said, there were no airplanes that could reasonably do a cross country trip. Or if it was a cross country trip, it would take multiple days to cross the country in the airplane. So I think before the interstate system and is developed, a lot of this is just done, essentially locally or train related crossings of the US.
So if there was a train already there, then wouldn't they already know how hard it would be to build a road? I feel like they would have that data.
Possibly. I feel at some point though, if you're trying to attempt to cross the United States or see kind of what condition your highways are in, especially for the mobilization of troops and other equipment, you got to start driving across the states at some point and see if your current transportation system can support something like this or if you need substantial development. Either way, it does not go very well. At least I don't think it goes very well for them in 1919 crossing the states. So they're dealing with poor quality bridges. I mean, they get broken crankshafts. They have clogged engines from desert sand. Like overall, I think it's probably a big wake up call for the states at this point that their transportation infrastructure system isn't developed to the point it needs to be or should be developed with what will become a big influx of passenger cars in the United States. Also, this is 1919, so we're in the infancy really of people having personal transportation vehicles.
Fair enough. In 1921, the U.S. developed the Federal Aid Highway Act, which provided $75 million allocated annually and sought for the construction of the interconnected, quote, primary highways with the intention of interstate cooperation on transportation planning. And the U.S. interstate system is born. The Bureau of Public Roads asked the Army to provide a list of roads it considered necessary for national defense, which was compiled by General John Pershing in 1922, and it consisted of 32,000 kilometers or 20,000 miles of roads, and that's been referred to as the Pershing Map. Automobile traffic increased throughout the 1920s and 30s, and planners developed the largely non-freeway U.S. numbered highway system. And by the late 1930s, they saw the planning of a new, large superhighway system, which we now call the U.S. Interstate System. The first formal description of the Interstate Highway System was put forward in 1939 by the Bureau of Public Roads Division of Information Chief Herbert Fairbank.
Moving forward a little bit in time, now President Dwight D. Eisenhower signs the Federal Aid Highway Act of 1956, which is also known as the National Interstate and Defense Highway Act, into law, which provides $25 billion for the construction of 66,000 kilometers of highways. And at this point, it is the largest public works project in American history. So the defense part of this is important, I think, for a couple of reasons. So firstly, some of the original cost is diverted from the defense fund. And secondly, one of the primary purposes of the interstate system is to provide access to all U.S. Air Force bases Navy bases, and Army bases during a conventional or nuclear war with the Soviet Union or its communist allies. So in the 1950s, we're in the infancy of the Cold War. More military planning is going into how do you mobilize various assets, how do you transfer them quickly between places in the States. So the interstate system is going to become a very crucial piece in troop mobilizations. Money for the Interstate Highway and Defense Act is placed in a highway trust fund that is 90% funded by the federal government and 10% funded by the states. So funds for this, since they don't magically appear out of thin air, these are generated through new taxes on fuel, automobiles, trucks, and tires, which I think is a really good way to fund your new highway system. So the primary users of the system are generally paying for the system. So that's fuel excise taxes, various taxes on tires and automobiles. It's unfortunate that taxes are out there, but I feel it's a pretty good way to get benefit out of your taxes. So the federal portion, the 90%, is largely paid for by taxes on gasoline and diesel fuel that is sold throughout the United States.
And I think a lot of these taxes are still in place to some extent. And one of the other ones that's commonly used nowadays is tolls. When they build a new road or a new bridge, oftentimes, if they're short on funding, they put a toll on that bridge or road until the construction and potential maintenance is paid for, and then they oftentimes remove the toll. Not always, but there are a lot of instances. I know there's bridges we've covered on this show where the tolls were removed once the bridge was paid for. So that's another way that they try to recoup some of those costs. So the Interstate Highway and Defense Act and the plan that they put in place drew inspiration from Eisenhower's experience when he crossed America in 1919, going 82 kilometers a day. And it was also based on the Reich's Autobahn system that Eisenhower saw when he was the supreme commander of the Allied forces in Europe during World War II.
The Reich Autobahn system is a system over in Germany, basically their interstate system in Germany. Germans had this first. Eisenhower drew a lot of inspiration from seeing that, from seeing how well goods and people and troops could be moved around on the system. So this comes into the plan for the US interstate system.
And I think we've all heard of the Autobahn in some form or another. It's the infamous highway that has no speed limits for at least sections of it, which seems very cool and dangerous all at the same time. General Lucius Clay was appointed to head a committee charged with the implementation of the plan, and Clay stated, quote, "It was evident we needed better highways. We needed them for safety, to accommodate more automobiles. We needed them for defense purposes, if that should ever be necessary, and we needed them for the economy, not just as a public works measure, but for future growth." Clay's committee proposed a 10-year, $100 billion program which would build 64,000 kilometers or 40,000 miles of divided highways linking all American cities with a population greater than 50,000 people. The initial proposal was to have a system of toll roads, but that was scrapped due to not being feasible outside of populated coastal areas, and was eventually funded by the previously mentioned gas tax.
On to the construction and the layout of the U.S. interstate system. I think the layout portion of the interstate system is really neat.
I agree.
So in the U.S. interstate system, major east-west interstates, so the ones that cross from, say, the west coast to the east coast, they end in number 0, and they increase going south to north. So an east-west highway or east-west interstate highway that would go through, say, the southern states like Louisiana, Florida, that would be Interstate 10, and then the numbers increase going north. So if interstates that go through, say, Michigan and the northern states, those would be Interstate 90. So they end in 0. It's a major highway. It crosses east to west in the country. Lower numbers further south, higher numbers further north. So the major north-south interstates, they end in 5s, and they increase west to east. So Interstate 5 goes from Mexico to Canada through California, Oregon, and Washington. Interstate 75, again, it ends in a 5, so it runs north-south. That would be on the east coast. So the numbering system, when you look at the numbers, they have some sort of meaning for where they are in the country and the direction that they run. There are, of course, exceptions to this because there are always exceptions to it, but this is the general rule. If it runs east to west across the country, it's going to end in 0. If it runs north to south, it's going to end in 5. And the numbering for the highways Lower numbers are on the southern part and also the western part of the country. Further along, so as we go into medium interstate highways, so not as major highways, they have either odd or even numbering. So the even numbers are east-west highways, odd or north-south highways. So there are exceptions again to this. There are medium interstates that have the same number. For example, Interstate 76 is in Colorado, as well as the interstate number for the Pennsylvania Turnpike. So as long as they're not connected together, they can have the same number. So geographically, they should be further apart just so it reduces confusion. And then minor interstates, they have a 3-digit number, and the numbering for these is slightly more complicated, but still makes some sense. So if the first digit of the 3-digit number is even, the interstate will eventually branch back to its parent. So these are used for bypasses, ring roads, beltways, things that go around significant landmarks or cities. And if the first digit is odd numbered, that is a spur highway that doesn't connect back to the parent highway. And the way that these are numbered, for example, so Interstate 294 is a loop that has connections on both ends to Interstate 94. And then, for example, Interstate 787 would be a spur route that attaches to Interstate 87. So there is some thought and logistics that have been put into the highway numbering system. They don't just randomly number the highways. So if you're traveling to the States on a business trip or a personal trip and you're driving a car, you can figure out generally what's going on with the interstate highway system. I think it's kind of cool. Some people might disagree. No matter what, it's going to be complicated. There's tens of thousands of miles of roads. This is a pretty good way, I think, to number the roads.
That is really cool. I knew about the major routes, but I didn't know about the medium and minor routes. And I'm right now trying to commit all of this to memory in case I ever get lost or I want to sound really cool on a road trip. I don't know how much of it will stick, but I'm trying really hard.
So we'll go a little bit further down the numbering rabbit hole because I think this is really cool. Exit numbers are generally rounded to the nearest mile marker for the interstate system. So this way, if you're on exit or if you need to take exit 275 and you're currently passing exit 265, you can know that in 10 miles your exit is going to be coming up. If there are multiple exits at, say, at exit 275, then they get letter designations after them, so 275A, 275B, 275C. So again, there is some logistical reasoning to this.
The first state to complete mainline interstate highway construction was Nebraska in 1974 with the dedication of I-80. So go Nebraska, really kicking it off.
They're finally first in something besides corn production.
I-5 connects Mexico and Canada through California, Oregon, and Washington State, and which Brian mentioned, and that was completed on October 12th, 1979. East-west completion of I-80 that runs from San Francisco to New Jersey was completed on August 22nd, 1986, and at the time of completion was the longest contiguous freeway in the world. Interestingly, the final section of I-80 to be completed was only 80 kilometers or 50 miles away from where the Golden Spike was driven that completed the first transcontinental railway in the US. And the original interstate highway system was proclaimed to be completed on October 14th, 1992, with the opening of I-70 through Glenwood Canyon, Colorado. And this section is considered an engineering marvel, which is pretty exciting, with a 19-kilometer or 12-mile span featuring 40 bridges and numerous tunnels. And it's one of the most expensive rural highways per mile built in the US. For those of you who haven't been to Colorado, there's a lot of mountains and rivers there, so that's not overly surprising.
So on a more numbering, I talked a little bit previously about how the interstates were numbered throughout the continental states as well as the exits from the interstates. Nicole did mention that there are interstate highways in Hawaii, Alaska, and Puerto Rico. I realize that those states are isolated from other states. They still have interstate highway systems. Don't overthink this. Part of the interstate highway system is that highways have to conform to certain design standards for, things like divided highways and exit lanes and controlled access and breakdown lanes. So these highways, even though they don't connect to other states, they still comply with the Department of Transportation requirements for interstate highways, so they get the interstate highway designation. So Hawaii, they have a prefix that starts with an H. Puerto Rico's interstates start with PR. Alaska starts with A. Makes a ton of sense. In Hawaii, there are 3 interstate highways and 1 auxiliary route. These connect a bunch of military bases and naval bases together. They also, unsurprisingly, provide a vital transportation link between communities on the island of Oahu. So mile markers on the states for numbering, they generally start at the south or the western state line if the interstate originates within that state. So ring roads that I mentioned before, interstate ring roads, so they're the 3-digit guys that go around cities. They have an even first number. These ones for numbering for mileages, because obviously it's very complicated to number a mileage on these. You have to have some sort of origin point for your mileage system. So the mileage goes in a clockwise direction, and it starts just west of another interstate that bisects as close to the southern part of the ring road as possible. So you can have a ring road where to the west of one point it will have mileage marker 0, an increase, and then if you look to the east, you could have mileage marker 75. Just due to the nature of this having a circle, you have to have an origin point for these somewhere. It just so happens that's how they chose it. Going west, it increases from whatever the closest interstate that intersects to the south is. Then there's also interstates that kind of have a north and south designation or east and west, just depending on the general direction that the interstates run. So there are nuances, like I said, to this numbering system. There are some logistics that kind of went into it, and then there's also just a bunch of exceptions that are just there.
Fun fact, the I-19 in Arizona is actually measured in kilometers instead of miles because when it was constructed, there was a push for the US to convert to the metric system. And as I'm sure you all know, I am a big fan of the metric system. I think it is the more superior measurement system. It all works together. They're all multiples of each other, and you're using even numbers. 1 meter is 1,000 millimeters, and it's 100 centimeters, and there's 1,000 meters in a kilometer. It's just really easy to convert from different parts of within the metric system. 1 liter of water weighs 1 kilogram. So there's just a lot of things about the metric system that make it really easy to figure things out in simple conversion. And I'm just a huge fan of it.
Yeah, it's a base 10 system instead of a bald eagle to washing machine based system.
Exactly. So the highest point of the US interstate system, Brian mentioned, is 3,400 meters or just over 11,000 feet above sea level at the Eisenhower Tunnel on I-70, which is at the Continental Divide in the Colorado Rocky Mountains. The lowest point of the interstate is negative 16 meters or negative 52 feet below sea level at the New River near Sealy, California. The most interstates in a single state are 32 routes in New York, which cover just over 2,800 kilometers or 1,750 miles. And the most primary interstates in a state is Illinois with 13.
So as I mentioned, the Interstate Highway System, it improved the mobility of troops to and from airports, air bases, naval bases, and army bases. One of the things that I thought was a fact about the U.S. interstate system that I'd heard many, many years ago was that every 5 miles, I believe every 5 miles, there's supposed to be a 1-mile straight section of the interstates to facilitate landing and takeoff of aircraft during times of war. All of the research I did for this episode basically said that was a giant urban myth, which kind of makes sense. Unprepared surfaces like highways are not exactly great for landing and taking off of airplanes. There's tons of signage, there's drainage ditches, there's signs over the highway, there's signage on the side of the highway, there's jersey barriers. It's not an ideal situation to land or take off an airplane. So probably one of those things that started back in the 70s or the 80s. I repeated it, I know 20 years ago, 30 years ago when I heard it. Not the case from all of the research that I did for this episode. However, one of the cool things about the interstate system is that it is reversible in times of natural disasters. At least in theory, it's reversible. So one of the procedures that they can do with the interstate system, which is known as contraflow lane reversal, is what would be an inbound lane into a city during times of, say, hurricanes or tornadoes or other natural disasters. They can reverse the flow of those lanes so that all of the lanes are outbound going instead of inbound to the city. So in theory, it would basically double your capacity to get people out of a city. This has had mixed results just with people not being familiar with the procedure. There have been people that have stopped to ask state troopers, like, what way to go, just other slowdowns with traffic. So some instances of evacuation have worked out pretty well. Other ones have worked out not as well. So this is a system that continually is refined. I hope that in future natural disasters, once it's been practiced a little bit more and probably implemented a little bit more, that it can see less people losing lives that stay within cities during natural disasters.
So we've talked a lot about the good things from the US interstate system, but there have been some negatives. One of the things I think I want to mention is that due to the success of the US interstate system, as well as the success of highways in Canada, North America is very much a car culture region. And because of that, we have very poor transit options, and getting around without a car is very, very difficult. And the transition from this car culture to some type of public transportation has been very, very challenging because we don't have high ridership. People are fairly resistant to spending on these systems. But I think as we try to make more sustainable design choices, a transit system that services a large population has the potential to be a very effective option because you can move a lot of people with less area, less land area, and less energy. But I mean, I have a car. I drive my car around the city. There are certain parts of the city that I prefer to drive to, and there are certain parts of the city that I prefer to take transit. I don't live too far from downtown, and so I usually take transit if I'm going downtown because I think by the time I drive there and park, I can get there just as fast on the train, and the train allows me some time to walk outside. But there are a lot of parts of the city that aren't accessible. They're not convenient to get to by transit at all, and so I drive. So I get both sides of it. I just think it's just interesting how we've kind of gotten to this point and I'm interested to see how we'll move forward. In addition to that, more than 475,000 households and 1 million people have been displaced during construction as the highways cut through neighborhoods and residential areas. And the areas impacted were largely Black or poor neighborhoods, which led to increased segregation, physical buffers in communities, and served as a way to isolate communities of color. And I'm going to call this, it's not quite environmental racism, but it's kind of where you put these really unpleasant and potentially unsafe highways to isolate certain communities from others. It's just, it's really unfortunate. U.S. Transportation Secretary Pete Buttigieg unveiled new efforts to address the problematic racial legacy of interstate highway construction with a $1 billion plan to reconnect cities and neighborhoods racially segregated or divided by public projects.
So there you have it, the US Interstate Highway System, a massive undertaking that started with a 62-day trip across America along largely unpaved roads that eventually led to the construction of more than 48,000 miles of divided highway that crosses the United States and is a vital link in the lives of people, commerce, and military endeavors.
For photos, sources, and an episode summary from this week's episode, head to failureology.ca. And if you're enjoying what you're hearing, please rate, review, and subscribe to Failureology so more people can find us. If you want to chat with us, our Twitter handle is @Failureology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us on our Patreon page. And check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode for our first of a 2-part series on the history of NASCAR race car safety. And I think we're going to break it up into 2 parts. We're going to do one episode before the Dale Earnhardt Sr. crash and then kind of everything that's changed since then. Because Brian's more of a fan than me, but I think that crash was a pivotal moment in NASCAR safety features. And so I think that's a great kind of breaking point for that 2-part series. But anyways, more on that next time. Bye, everyone. Talk soon.